The stars above me are closing in, so water roll me home.
D-2 Inc. Oceanography News.
Day will come, but not as long.
Welcome to D2 Oceanography and Marine Science News, Episode 4. In this week's episode, we're featuring a story regarding Iceberg A23A, which has broken free. And here you can watch satellite video, which shows the world's largest iceberg, A23A, breaking free and drifting out into the ocean. The world's biggest iceberg is on the move. Meet A23A. It's twice the size of Greater London, weighing almost 1 trillion tons. This megaberg calved from the Filchner-Ronne ice shelf in 1986, then it got grounded in the Weddell Sea for 30 years, started moving again in November 2023, and has been on the loose in the Southern Ocean since. Then A23A was trapped in a Taylor column. These rotating waters form underwater mountains. This one kept A23A spinning for months and delayed most melting. A23A has just escaped. Scientists are monitoring A23A's impact on ocean ecosystems. A23A, the world's largest and oldest iceberg, is finally cruising again through the ocean waters after an unexpected delay. This summer, A23A got stuck near the South Orkney Islands, twirling in what's known as a Taylor column. Satellite video showed the iceberg spinning whimsically in place, a process that also delays melting, and then finally breaking free. As NPR's Juliana Kim reported in August, the Taylor column is a fluid mechanics phenomenon that can be described as a rotating cylinder that forms when there's an obstruction in flow, in other words, an ocean vortex. Of course, this is just a blip in the long storied life of A23A. After first calving or breaking off from Antarctica's Filchner ice shelf in '86, the iceberg spent some 30 years grounded in the seafloor of the Weddell Sea. In 2020, A23A escaped and began its slow journey north before being caught up in the Taylor column. The mega iceberg weighs nearly 1 trillion tons and is about the size of Rhode Island, according to the British Antarctic Survey. Laura Taylor, a biogeochemist, observed A23A up close and personal last year aboard the British Antarctic Survey's Biopole cruise. That these giant icebergs can provide nutrients to the waters they pass through, creating thriving ecosystems in otherwise less productive areas, she said. What we don't know is what difference particular icebergs, their scale, and their origins can make to that process. Samples from the environments touched by A23A's path will give insight into the life that could come in its wake, the impact it could have on carbon levels in the ocean water, and its balance with the atmosphere, Taylor said. That is increasingly important as climate change leads to warmer temperatures and rapidly melting ice caps and glaciers. So what's next for this Antarctic darling? The British Antarctic Survey says that if all goes according to their predictions, A23A will continue its journey into the Southern Ocean following the Antarctic Circumpolar Current, which is likely to drive it towards the sub-Antarctic island of South Georgia. There, the survey predicts the iceberg will encounter warmer water and is expected to break up into smaller icebergs and eventually melt. But if there's anything we've learned about this funky iceberg, it's that things don't always go according to plan. A study that was similar to the monitoring of A23A's wake was our work in the Ocean Monitoring Initiative in the Arctic, where we used D-2 Inc. CTDs on ice-tethered profiler platforms in order to measure hundreds of meters down below the ice to provide conductivity, also known as salinity, temperature, and pressure data, which was vital to monitoring what's going on in the Arctic. If you'd like more information on this, go to our website, d2.com, and go to news, or visit the link in the description for this video. Thank you. You can see a blue glacier being formed. This video comes from Oceanography on Twitter. As covered before, the AMOC, the ocean current vital to regulating our weather. Here you can see it's being studied with a water bottle sampler and a rosette that you could attach a CTD to, and you should be using a D-2 ink CTD to study this. Oceans move vast amounts of water, heat, chemicals, and microscopic life around the planet, with one ocean current particularly crucial to life on Earth. The Atlantic Meridional Overturning Circulation, or AMOC, is vital in regulating the temperature of the Earth. This is something we've covered in previous episodes. Scientists measure it using scientific instruments deployed in different latitudes across the North and South Atlantic Ocean. Studies have suggested it will slow down or even collapse, which could have a catastrophic effect on our climate and lead to even more extreme weather. The National Oceanography Center in Southampton has been studying the AMOC for 20 years, and it believes it will need at least another 10 years to see if climate models which predict the future are correct. On the vessel studying the AMOC is the RRS Discovery, pictured here. This is an image of the crew of the RRS Discovery as they are out on station. Pictured is Dr. Tillis Pettit, who is a research scientist from the NOC, who was on board the RSS. Pictured here is Dr. Ben Mote, who's a physical oceanographer at NOC, who's been on a 2-week expedition on the western side of the Atlantic. He's also on board the RRS Discovery. They were servicing moorings close to the coast of the Bahamas off an island called Abaco, where they observed the AMOC. He said, "We do this by a series of tall moorings that go from the seabed at 4,000 meters to close to the ocean surface around 50 meters. We also have these tall moorings on the eastern side of the Atlantic around the Canary Islands." RRS Discovery works 24 hours a day, and there are 55 people on board, including 28 scientists. Dr. Mote said, "We bolt maybe 20 to 25 instruments onto the wire, and they measure the temperature of the water, the pressure or the depth that those instruments are at. We also measure the salinity, so how salty the ocean is. All of these are measurements that the D2 ink CTD can do." Scientists use these measurements to inform climate models, which give them a glimpse into the future. When the first data started coming back in 2005 and 2006, this observational system we have here, it revolutionized our understanding of this ocean circulation, Dr. Mote said. "We can make measurements here now, but we can't make measurements into the future. We have to use big mathematical climate models, and they predict that in the future, this ocean circulation will weaken." The AMOC moves 17 million cubic meters of warm water every second north along the ocean surface, returning cold water through the ocean depths. This distributes 1.2 petawatts of heat, the equivalent to the energy flowing through 1 million power stations. It exchanges heat, water, and carbon with the atmosphere, helping to control our weather in Europe and marine ecosystems. Climate change is causing the planet to warm. With the simultaneous warming of the seas, the ocean's capacity to take up carbon dioxide and store it will decrease. Dr. Tillis Pettit, who is a research scientist at the NOC and who was also on board RRS Discovery, said, quote, "A decline in the AMOC would have huge consequences for our climate because it directly regulates our climate. The idea is to have these moorings at two sides of the Atlantic to be able to measure the AMOC, the rate at which heat transports north towards the Arctic." Southern Ocean Study challenges key carbon pump theory. A new UK National Oceanography Center-led study has put a major question mark over the role a unique group of tiny microscopic plants plays in driving ocean carbon storage. Diatoms, a type of plankton or marine algae, have a significant role in drawing carbon down into the deep, especially in the Southern Ocean, which takes up about a third of organic carbon stored in the ocean. Uniquely, diatoms have dense silica-based exoskeletons like miniature glass houses, which were thought to provide ballast, making them prone to sinking, and therefore a key way carbon is transported to the deep ocean. But the new study, based on data from 2 major expeditions to the Southern Ocean's underexplored twilight zone, the region between 100 meters and 1,000 meters deep, found that the diatom skeletons lingered near the sea surface while carbon made its way to the deep ocean by other means. The ocean plays a key role in the globe and carbon cycle, with tiny microscopic plants taking up billions of tons of carbon from the atmosphere every year, explains research lead Dr. Sari Gehring. Research led at AMOC, for years it has been believed that this group of plankton diatoms play a crucial role in efficiently transporting carbon to the deep ocean, where it is held out of contact with the atmosphere. Over 2 expeditions, each lasting more than 5 weeks at sea, AMOC scientists and international colleagues studied the twilight zone at 4 different sites in the Atlantic and Pacific sectors of the Southern Ocean. This included iron-rich waters around a remote chain of islands and nutrient-starved waters in the open ocean. The collaborative team used a combination of innovative techniques, including ship-based measurements, mooring arrays, and autonomous underwater technologies. Surprising discovery that diatom silica skeletons stay near the surface while carbon makes it down to the deep ocean forces us to rethink the ecological processes in what we call the biological carbon pump. The biological carbon pump describes a collection of processes in which plankton take up carbon in surface waters and shunt this carbon to the deep ocean. These natural processes store billions of tons of carbon in the ocean each year. Previous studies have looked at what has ended up at the seabed, which shows carbon is making its way there, typically with the aid of ballast material such as diatom silica-based skeletons, adds Dr. Gehring. But our research, looking at what happens within the twilight zone before carbon reaches the seabed, shows that diatoms are at times not contributing as heavily to the Southern Ocean's carbon pump as had been thought. This means there are unknown or poorly measured processes happening in the deep ocean that we need to learn more about. Why are the seas surging? Fort Pulaski Tide Gauge sits on a small, narrow pier just 15 miles east of Savannah, Georgia. It is one of more than 100 stations across the country that track high and low tides, temperatures, wind speeds, air pressure, and the rising seas. For 90 years, the station has returned a steady stream of data to scientists, locals, ship captains, helping them track the rhythms of the ocean and avoid perilously low tides. It has also shown a dangerous trend. Since 2010, the sea level at the Fort Pulaski gauge has risen by more than 7 inches, one of the fastest rates in the country, according to a Washington Post analysis of NOAA data for 127 tide gauges. Similar spikes are affecting the entire U.S. Southeast, showing a glimpse of our climate future. The United States has been recording tides for around 2 centuries. In the early 1800s, tide gauge were simple vertical shafts placed in the water, with individual monitors checking them every hour and recorded data by hand. Later, an American inventor developed a tide gauge that recorded the levels without human intervention. A float rested on the top of the water, connected to a pencil above that traced out patterns on a recording sheet. Now the technology is much more sophisticated. NOAA's tide gauges are outfitted with backup sensors, satellite communications, a version of GPS that allows precise measurement of the gauge height from a network of satellites around the globe. The data has been critical for navigating harbors and channels, predicting the best time for fishing, and spurring trade. But today it has taken on an even more urgent role, helping to track the seas rapidly rising due to human-driven climate change, and in some spots, like the area around Fort Pulaski, that sea level rise has accelerated. The UN IPCC projects that the planet will experience between 1 and 3 feet of sea level rise by the end of the century, but that's a global average. Many people think of the ocean like a bathtub, turn on the faucet and water level rises equally everywhere. As the planet warms and ice melts, they assume the ocean might act in the same way. Sea level rise, however, is very uneven. Thanks to a complex set of factors, water levels are not rising at the same speed everywhere. These factors have made the U.S. South particularly vulnerable. There are many non-intuitive things that happen as global sea level rise, Piquet said. Along the U.S. Southeast Atlantic coast, an area that stretches from Florida to North Carolina, 3 factors have combined to drive faster sea level rise than most places in America, according to scientists. Ocean warming scientists say largely accounts for rapid acceleration of sea level rise in the southeast over the past 14 years. But mysteries remain. Only the U.S. Southeast, specifically the area south of North Carolina's Cape Hatteras, has experienced faster sea level rise than scientists predicted. In the Northeast, waters are rising, but more in line with projections. Scientists suspect part of that is because of the Gulf Stream, a long band of warm water that follows the coast up from the equator and then near Cape Hatteras turns out into the Atlantic Ocean. The waters of the Gulf Stream and the Gulf of Mexico are warming faster than other parts of the Atlantic, boosting sea levels. The Gulf of Mexico has warmed exceptionally fast over the past decade and a half, Pachuk said. It's uncontroversial. Scientists have puzzled over where all the heat is coming from. That's exactly the part where we all passionately disagree, Dangendorf said. You could ask the three of us and you'd probably get three different answers. Dangendorf believes that the heat is coming from the winds pushing warm waters from the east to the west in the Atlantic Ocean, and the ocean currents forcing that warmth toward the Atlantic coast and into the Gulf of Mexico. But other researchers like Liping Zhang at NOAA's Geophysical Fluid Dynamics Laboratory think the heat may also be coming from changes in the Atlantic overturning circulation, a massive ocean current belt that moves heat from the equator to the poles. What's definitely known for sure is more investigation is needed, which would require D-2 ink CTDs to measure the temperature changes in the ocean. For now, sea levels in the southeast are surging, and they provide an early picture of what most of the United States and the rest of the world will experience as oceans rise. Towns and cities near Fort Pulaski are trying to adapt, shoring up beaches and stormwater systems, and even considering retreating to higher ground as the waters approach. Other states and cities will soon see the same effects. NASA projections show that in the coming decades, many cities in the Northeast will experience up to 100 more days of high tide flooding each year. Some researchers think that the Southeast acceleration may be linked to long-term weather patterns in the Atlantic Ocean like the North Atlantic Oscillation. If so, the trend could switch in the coming decades, with areas of the Northeast seeing rapid sea level rise while the trend in the Southeast slows down. Zhang believes that the Northeast could see a similar acceleration in the coming years. I can only say that it is very likely, she said in an email. Locals on Georgia's coast say that their experience can be a lesson for the future. We have to learn to live with the water, Palumbo said. Things that we're going through today, it is us today, but it'll be you tomorrow. This video comes from Oceanography on Twitter and is a video of a ship sailing through what's known as the Roaring Forties.
That's God. Oh shit. I'm not gonna lie, I was kind of scared then.
That's so good.
The gun just got.
Exhaust temperature, outlets.
Schmidt Institute, Canyons, Vents, and Seeps, oh my. During the 7th expedition of 2024, an international team of scientists on board the RV Falcor 2 surveyed nearly 20 methane seeps, some of which are new discoveries in 4 submarine canyon systems previously never seen before by humans. They found an abundance of animals, including possibly 60 new species, living in surprisingly diverse ecosystems off the Chilean coast, including commercially valuable fish swimming in seep areas. The 55-day expedition traveled to Valparaiso to Punta Arenas, Chile, exploring the ocean from the country's central to the southern coastline. Methane seeps are chemosynthetic environments where the methane bubbles up from the seafloor, feeding microbes that in turn support an array of life, while clues from the water chemistry measurements and images from the camera tows take on previous expeditions to the region suggested the presence of some seeps off of Chile. Many sites had not been fully surveyed and sampled before. In addition, several seep sites were entirely new to science. Some were in shallow waters, others in deep waters. Some were in rocky areas, others were in sediment. This expedition is yet another example of the tremendous value of bringing together cross-disciplinary science teams and cutting-edge technology to little-known regions of our global ocean, said Dr. Jyotika Vermani, Executive Director of the Schmidt Institute. The diverse marine life swimming contently in this geologically interesting ecosystem was beautiful to watch, a strong reminder that what is out of sight should perhaps not be out of mind. Thanks for watching out there, everyone. Make sure to like, share, and subscribe here on YouTube, and follow us on Twitter and on LinkedIn.